Hey guys, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to discuss about subtopic 1.5, the pigeonhole principle. So here are the objective of this subtopic where at the end of this lesson, I want everybody must know how to find the least number of pigeons if given a number of pigeonholes. Okay, so let's start with the introduction first. There are many problems in which an object with certain properties need to be determined. Okay, for example, there are 101 people booked for a trip and the plane only has 100 seats. That means at least 2 people must be assigned at the same seat. Another example, okay, there are 13 people in a room. That means at least 2 people must be born in the same month. So these two examples actually can be solved by applying the principle known as the pigeonhole principle. The pigeonhole principle is also known as the Dirichlet drawer principle, where the person that are responsible with this principle is Peter Gustav Dirichlet. Alright, so what is the pigeonhole principle? Okay, if k is a positive integer and k plus 1 or more objects are placed into k boxes, then there is at least one box containing 2 or more of the objects. So this is the example, okay, where we only have 9 boxes, okay, 9 pigeonhole, but we have 10 pigeon. So that means, okay, there is a pigeonhole that have more than one pigeon. So in order to apply the pigeonhole principle, we need to identify which objects are pigeons and also which objects will become the pigeonholes. Here are another examples that can be solved by using pigeonhole principle. Okay, so let's go one by one. Okay, the first one. Among any group of 367 people, there must be at least 2 with the same birthday because there are only 366 possible birthday. Okay, so in a year we have let's say we have 366 or 365 days. Okay, so we consider a year is a 366 days. Okay, let's consider all people have a different days of birthday. Okay, that means if we have 367 people, that means must have at least one people that have two same birthday. Okay, so for example number 2, if 8 people are chosen in any way from some group, at least 2 of them will have been born on the same day of the week. Okay, for this one, so 1 week, that means we have 7 days. Okay, if we consider all the 7 people born in the different days, that means if we have 8 people, at least one people will be born in the same day of the week. Okay, so how about example number 3? If any group of 27 English words, there must be at least 2 that begin with the same letter since there are 26 letters in the English alphabet. So this is exactly like the previous one. Okay, we know A until Z. Okay, A until Z we have 26. So since we have 27 English words, that means we at least we have 2 words that begin with the same letter. Alright, for better understanding, let's try some example. Example number 1. How many students must be in a class to guarantee that at least 2 students receive the same score on the final exam? If the exam is graded on a scale from 0 to 100 points. Okay. So from 0 to 100. So what is the total of the graded? So the total is 101. So by using the pigeonhole principle, so we must have at least, okay, at least 102 students, so that at least 2 students will get the same score. Alright, so now let's try for example number 2. Suppose the positive integers in the set A are less or equal to 32. Determine the least number of integers that must be chosen so that at least one of them is divisible by 3 or 5. Okay, so firstly, we have a set of numbers. So a set A, we have start from 1 until 32. Okay, so from 1 until 32, we have around, how many numbers for 1? Okay, we have total 32 numbers. Okay, so now let's list down, okay, the numbers that divisible by 3. Okay, so divisible by 3. So we have 3, 6, 9, 12, 15, 18, 21, 24, 27, and also 30. So total divisible by 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 here. Okay, how about divisible by 5? So divisible by 5, so we have 5, 10, 15, 20, 25, and also 30. So total here is 1, 2, 3, 4, 5, 6, 6. Okay, but if we compare divisible by 3 and divisible by 5, so there is same numbers, that is 15 and also 30. Okay, so from the total, okay, 10 plus 6, okay, is equal to 16, but we must minus the same numbers, that is 2. So total numbers that can be divisible by 3 and 5 is 14. Okay, so this implies that from the total numbers 32 minus with 14, so we have 18. That means 18 numbers cannot be divisible by 3 and also 5. So by using the pigeonhole principle, okay, determine the least number of integers, okay, that must be chosen. So at least one of them is divisible by 3 or 5. So that's mean by using pigeonhole principle, okay, so we must have at least 19 numbers so that one of that is can be chosen from divisible by 3 or 5. Okay, before this we already discussed about the pigeonhole principle. So now let's discuss about the generalized pigeonhole principle. Okay, if n objects are placed into k boxes, then there is at least one box containing at least objects. So the mathematically we can write as n over k is equal to m. And also if n over k is equal to m, then we can find the value for n. So where the formula is n is equal to bracket m minus 1 multiply with k and then plus 1. Where this symbol represents the ceiling function which assigns to the real number by the smallest integer that is greater than or equal to real number. Okay, for example, 1.3. Okay, we round up it to 2. Okay, 0.9. Okay, we round up it to 1. Okay, how about 25.56? Okay, 0.56. So we just round off to 26. And minus 3.65, we round off to minus 3. Okay, close to the largest integers. Alright, so let's go to the example number 3. So in a group of 100 people, what is the least number of people born in the same month for any given year? Okay, so from here, okay, we have 100 people. And also in a year, okay, 1 year, we have 12 months, okay, start from January until December. So from here, let's identify what is our objects and what is the place or the boxes. Okay. From this example, 100 people will be our object. So this will be our N. So 1 year equal to 12 months. This will be our places or our boxes. So this will be K. Okay, so based on the generalized pigeonhole principle, so we apply the formula. Okay, so we apply the formula with and divide by K. So we have N 100 divide by 12. So we will have 100 divided by 12 is equal to 8.3333. Okay, and by using because we use this bracket, so we need to round off the number. So we round off to the largest integers. So we have almost 9, at least 9 people. Okay, so here another example how to solve by using the generalized pigeonhole principle. Okay, for example number 1. In a group of 11 people, there are at least 6 men or 6 women. Is it correct? Okay, we can, our objects N is equal to 11 people. And then our place or our boxes K is equal to 2. That means female or male. Okay, female or male. So by using the formula N over K, so we have 11 divided by 2. Okay, 11 divided by 2. Okay, make sure you write the bracket correctly. So 11 divided by 2, you will have 5.5. So we round off. So we will have at least 6. So this is correct answer 6. Okay, the second example here. If any 30 people are selected, then 5 were born on the same day of the week. Is it correct? Okay, so what is the object? Object 30 people. So what is the places? Okay, our K is equal to day of the week, so 7. So by using the formula 30 divided by 7, so what you have? 30 divided by 7, you will have 4.2857. So we round off to the largest integer. So we will have 5. So correct answer here. Okay, the next example, number 3. In a group of 1099 people, at least 4 share a birthday. Okay, so what is your object here, guys? So our object is 1099 people. So what is the K? So value of K is it says about at least 4 share a birthday. Okay, so you will have 1 year we have 365 people day. Okay, sorry. So by using the formula N over K, so we have 1099 divided by 365. So we will have 3.01 okay, so we round off to the largest integers, we will have 4. So this is the correct answer. And the last example. Okay, for the last example, example number 4, I think you can try by yourself by using the previous example. Okay, so please try for this one. Alright, so let's try example number 4. What is the minimum number of students required in a discrete mathematics class to be sure that at least 6 will receive the same grade if there are 5 possible grades A, B, C, then F? Okay, so from here, so let's list out all the information that we have. So we have 5 possible grades. So A, B, C, D, and also F. So this one will be our boxes or K. And then what is our objects? N. So object is the number that we were going to find, where the answer that we get is at least 6. That's mean by using the formula N divided by K. So we have N is equal to the thing that we want to find. K is equal to boxes. We have 5. So we have our M is equal to 6. So this is our M. Okay. So now we are going to find the value of N, our object. So by using this formula, N is equal to M minus 1 multiply with K plus 1. So you will have our M is equal to 6 minus 1 multiply with 5 and then plus 1. So you will have 6 minus 1 is equal to 5. 5 times 5, 25. 25 plus 1 is equal to 26. So this is the number, okay, of minimum student that required in a discrete mathematics. Okay, so now example number 6. A box contains 8 green balls and 6 red balls. Okay, how many balls one must take out from the box to be sure that at least 2 balls have the same color? Okay, so we have a red and also a green ball. That means this will be our K. Okay, and then we are going to find the minimum number, okay, N, where at least, okay, 2 balls have the same color. That means M is equal to, so we are going to find the value for M. So by using the formula, N is equal to bracket M minus 1 multiply with K plus 1. So we will have 2 minus 1 multiply with our K is equal to 2 here, 2 plus 1. So we have 2 minus 1 is 1. 1 times 2, 2. 2 plus 1 is equal to 3. So at least you must take out 3 balls. Okay, so that means at least 2 balls have the same color. So I hope everybody can understand my explanation about this subtopic. So please study. Thank you guys. Assalamualaikum.